So I wanted to do a nice little review video from something that we learned in Pre-Calculus 1 that I'm hoping will kind of be a little fresh in your mind after you watch this video, because the next video in our series kicks off week 3, which is how to sketch the trig functions. Okay, and so what I wanted to start us with was let's kind of just pretend. Okay, let's pretend that we have some function f of x is equal to x squared minus x. Okay, let's pretend this is our function. Now, what does this look like? I don't know. I could graph it. I could plot points. I could figure out where the vertex is. There's a whole bunch of things we could do. That's not really my intention. My intention with this exercise is to simply remind you all of what happens when we take a function and we shift it around, okay? We start applying things like flips and reflections and stretches and things like that. So for instance, I don't know how right or wrong this is going to be. I'm simply just going to pretend that this function is going to look something like this. It's a parabola. I know it goes to the point 0, 0. I'm just going to say this is our parabola, okay? And now what we're going to do is we're going to run through our list, and actually maybe I'll make some more little graphs before we get started. But as I'm doing this, what we're going to be doing is we're going to run through our list of transformations. Basically, what happens when we do certain things to our function, right? What happens when we multiply the inputs by a number? What happens when we multiply the outputs by a number? All that good stuff. So, the very first transformation that we might do, I'll put 1, is what happens when I take that function and I multiply it by some number on the outside. Okay, so that is if I take a 2 and I multiply my function by 2. Well, what is this doing? This is taking all of my original y values and I'm multiplying them by 2, right? That's essentially what I'm doing. And so what this is going to do to our original graph is it's going to take all these y values that we had and it's going to shoot them up by a factor of 2, in effect making our graph skinnier and taller and increasing the height of it. So this first one I'm going to go ahead and sketch, and it's going to look something like this, and maybe under it I'll put the original. It's going to look something kind of like this, okay? So this graph right here is 2 f of x, okay? Something roughly like that, okay? Let's see. So what else could we do? What happens if I were to take my function and I were to multiply the inside by 2, okay? What is this going to do? So what happens if I take my function x squared minus x, and now I have 2x squared minus 2x, right? What does this do? Well, what this does is now we're messing with the input value, okay? We're basically saying that, if, for instance, before, if I were to plug in, x equals 1 and x equals 2 and x equals 3, over here, I'm moving twice as fast, because if I plug in x is 1 here, I'm actually really getting 2. If I plug in x equals 2 here, I'm actually really plugging in f of 4. I'm accelerating my process by a factor of 2, essentially. So what does that do to the graph? It actually is a very similar process to what just happened in the graph there on the left, where basically, right, if my original graph is at x equals 1 and x equals 2, well, if I'm trying to sketch this graph in orange, when I plug in x equals 1 on this graph, right, if I plug in x equals 1, I'm actually evaluating f of 2 in my original graph, and that y value is like all the way up here. So that means that I'm basically borrowing that y value, and I'm just going to pop it over to the 1 spot. And you can do this for all of them, and it's going to create, again, a very skinny graph like so, okay, with the original one being quite a bit wider, if you will. All right, because again, here is, at 2, here's that y value where it should have been, and it's been basically bumped over. It's been sped up and it's been used right there, okay? So that's the second transformation we could do. By the way, we call this a stretch, a vertical stretch, I should say. We call this a horizontal, there's a word for it, stretch shrinkage, I guess, horizontal compression. That's the right word, compression. Okay, roughly the same effect, all right? Now let's think, what else do we got? Number 3, what could we do? What happens if I take the function and I put a minus, I don't know, 2 on the inside of it, right? What happens if I shift my input? So x minus 2 squared minus x minus 2. Again, where is this coming from? I'm just plugging in x minus 2 for all my x values here. That's what we've done. And again, from pre-calc 1, hopefully you remember that this causes your original graph, which looks something like this. This causes your original graph to shift to the right by 2 units, okay? So now your graph is over here. All right, so that's what the blue one does. And then last but not least, what happens if we take our original function and I were to add, I don't know, 3 to it, right? So basically we have our original function, x squared minus x, and then all of a sudden I just decide to plop a plus 3 at the end of it. Like, what is that going to do? And again, from pre-calc 1, this right here is a vertical shift up 3 units, okay? So again, if my original graph is here, then my new graph is going to be somewhere up here because we have shifted all the points up by 3 units, all right? Now, there are other things that we could do, right? If I take the original graph and I put a negative in front of it, right? What does negative f of x do to our graph? So maybe I'll sketch this as well. So boom, 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 boom. So if the original y values were up here, well, what does putting a negative in front of this do? So basically we have negative x squared minus x now. What does this do? Well, it takes all your original y values and it flips them on their head. So your new graph does this. Okay. The last one, which I'm not going to draw, but is what happens if you have f of negative x, right? So if I put in a negative x squared minus negative x, right? If I plug in negative x for everything, and this right here results in a flip over the y-axis, okay? But for us, if you take a parabola that's centered at the origin and you were to like flip it right over the y-axis, we're just going to get the same graph. Okay, now if for instance this graph, if I've drawn it incorrectly, right, maybe this parabola actually sits like somewhere over here, then what would it look like when I put in the minus x? It's going to be the same graph. It's just going to be reflected over the y-axis, right? That's what's going to happen over here, okay? So this is just a very short video to remind you of these things because we're going to be talking about trig functions and kind of what they look like and how to graph them and stuff, and we're going to use some of these very similar techniques to help us sketch those functions.